There's some basic concepts that you need to know before you actually start in cryptocurrency investigations, and one of them is how the blockchain works. There are a lot of different cryptocurrencies, and they all have their own feature that makes them special, but underneath all of that is this core concept of a blockchain that pretty much all of them use. Now, the way those blockchains individually work may be a little bit different, but as long as you understand that core concept of blockchain, you should be okay. So let's think about how blockchain works. Let's say we have a transaction, and we want to record this transaction somewhere. We'll say this line represents where we're going to record it, or our ledger system where we're going to write information about our transaction. Now, I want to exchange money, so I want to give some currency to my friend, for example. We make a transaction record on this ledger system, and it has, for example, the amount of money that I'm going to include. It has who the money is going to, and then of course where it's coming from. So now we have the amount of money we have to and from, and then that's recorded on a ledger system. We'll come back to where this ledger system actually is in a second. Somebody else is also using this ledger system, and they want to transfer money to their friend, so they create another transaction record, and then it also has, for example, the amount of money that they're transferring, who it's going to, where it's coming from, and then the next thing that they add is also information about the first transaction that happened, so specifically the hash value. We create a hash value, and I'll just call it H1, and then we put H1 into the transaction record, and now what I can do is use H1 to verify this past record. Now, we can keep doing this all day long, adding more and more transactions to the chain. Once I get to my last chain, then I have, for example, the $, to, from, and then H in, so whatever the most recent value is. I can use that hash value to validate the previous block in the blockchain, and if that hash value is correct, then all of the other hash values are correct down the chain. So this is a very basic system for making sure of the integrity of the overall chain. This is really all blockchain is. It's just a transaction record with information about hashes for prior transactions that are in the current record. That way we can do validation all the way back. This also means the more transactions we have, the harder it is to modify prior transactions. So for example, I would have to modify everything in the line if I wanted to go back and modify the H1 value. This ledger system that we're writing everything on is distributed. I can have my own node or my own computer keeping track of all of the transactions. Everyone else who's participating in that particular network can also have their own node monitoring and validating transactions. All of these nodes have their own copy, essentially, of all of these records. They're constantly doing validation against all of those records and making sure that everything actually is valid. So if one of these nodes comes in and says the value of H1 was, 23, then all of these other nodes will go, no, that's not what I have in my record, and then they would reject that node's update. Pretty much all blockchains have some type of validation network, and usually it's distributed. So for example, Bitcoin. People really like Bitcoin because the ledger system that they use is globally distributed. A lot of different countries, organizations now are in that network. So that's a lot of different groups validating the blockchain or all of the transactions on the blockchain all the time. There's other systems that aren't quite as distributed. So for example, one company might own all of the nodes that validate transactions. Banks can use blockchain to keep track of all of their records. It's a really good use case for banks. But the banks themselves probably don't want to distribute their node validations with other organizations. They wouldn't want to make it public necessarily. They could have, for example, several nodes running their own blockchain and then doing all the validation themselves. This is where blockchain gets a little bit tricky, a little bit interesting. If we have a fully public blockchain, then that means that anyone can join the network and then try to validate and potentially try to maliciously alter some of the transactions in that chain. We could have a globally distributed blockchain system, or we could have a blockchain system that is controlled essentially by one or only a couple companies, or just a single entity. One node validating those transactions would still work in terms of blockchain. Now, whenever we talk about most of the popular cryptocurrencies, they are globally distributed, and lots of different competing interests can validate transactions on that ledger system. The way that the blockchain is maintained determines how susceptible it is to certain attacks. So we have a ledger system, and this ledger system, this information is completely distributed to all nodes on the network. It could be public, which means everyone can get access. It could be private, which means a single organization has that information. Some layer is validating new transactions that are added to this ledger system. So we have a way to record transactions that is very, very difficult to modify. And over time, it just strengthens the overall chain. So we can put all sorts of information into this ledger system. It doesn't have to be just, how much money was transferred or whatever. I could record, for example, usernames. Let's say that I own a website. I have a transaction. I have the username here for, let's say, user 1. And this user obviously could update their username. We don't modify this particular transaction. Instead, we write a new transaction, update the username to UN2, something like that, right? So I've edited now the username. In my system, whenever I'm going through it, I can just check for the latest version of that username that's in the blockchain. And then that gives me history of all of the username changes that have happened. In most ledger systems, you cannot edit transactions. That's completely against the point. But what you can do is submit a new transaction that updates prior information and then prefer the newest copy or version of that information. In the ledger system, we have this kind of validation layer and we have transactions. We can develop it so that way we can store anything in this ledger system. And the ledger system is extremely powerful. So when we're talking about blockchain, think about keeping records that should not be able to be changed. So if this is our ledger system, where does cryptocurrency come into play? Cryptocurrency kind of sits on top of this ledger system, and most popular cryptocurrencies tend to have their own kind of ledger system in place, or they ride on the back of another cryptocurrency's ledger system that it's already well established. So we have this application layer, and that can usually be something like a cryptocurrency exchange or maybe a cryptocurrency wallet that a user has. And these wallets can do a couple different things, which is why it can be a little bit confusing. They can, in some cases, try to validate transactions through the wallet. They can also interact with the ledger system and add new transactions to the ledger system. Basically, they're participating in a network with other nodes on that network. So think of a wallet as essentially a unique identifier, and this would be for example, your Bitcoin address. And using that Bitcoin address, you can both submit new transactions and also receive transactions. So a wallet is essentially just an interface for the ledger system. And cryptocurrencies are just value that's created at this application layer. So that's kind of the basics of blockchain. We have some sort of ledger system, and that is a chain of blocks or a chain of transactions that happen. We have some sort of validator system network sitting underneath there, continuously validating transactions and adding new transactions to the chain. And then this application layer, which is where the users are using a wallet to interact and attempting to submit new transactions or read transactions from that ledger system. In most cases, if you just think about cryptocurrencies in terms of the ledger system for investigations, it's going to be way more straightforward. So I hope that was helpful. A little quick introduction into the basics of blockchain. Validation mechanisms are different. Even the way the blockchain works and what types of information can be stored are a little bit different, but this will at least get you started. Thank you very much.